We are going into the final panel discussion, which is about the future and which is about the role of young engineers in allied industries. The speakers are Dr. Kaushik Bhattacharya representing SAIL, and we also have Mr. Saumabha representing TCS, Mr. Ajeya Bandyopadhyay representing IFC World Bank Group, and Dr. Asim Roy is going to be the moderator. Dr. A.K. Roy is a chemical engineer of great repute, and indeed research and development is his strong forte. May I request Dr. A.K. Roy to please come up on the dais and call his panelists. As we all know that he was the person behind the establishment of many iconic, let's say, achievements in the steel industry. Dr. Ray was instrumental in commissioning sponge iron pilot project and associated processes in the research laboratory. Dr. Roy is also a great academic who has published many books. He has received many awards. In fact, under his leadership, DSP, that is Durgapur Steel Plant, got the prestigious Golden Peacock Award. And he, as I was saying, that he has a number of publications, and he got the best paper of the year in 2021 from the International Society of Automation, United States. It is, before I hand over the mic to Dr. A.K. Roy, may I call upon our head of the department, who would be felicitating Dr. Ray and the panelists. Our head of the department, Professor Rajat Chakraborty, to present a memento and felicitate Dr. A.K. Ray. And also to the panelists, Dr. Kaushik Bhattacharya, representing SAIL. Dr. Kaushik Bhattacharya, representing SAIL. And we have Mr. Saumabha Barua, representing TCS. Saumabha Barua, representing TCS, and Mr. Ajeya Bandyopadhyay, representing the IFC World Bank Group. Thank you so much, and it is over to Dr. A.K. Ray to conduct the proceedings.
So this is the last panel discussion, and topic of this discussion is on role of young engineers in allied industries. And we have a very learned panelist like Dr. Kaushik Bhattacharya. He is in the marketing division of Steel Authority of India Limited. Mr. Saumabha Barua, he was also in Steel Authority, as I understand. He was there for some time, and then presently is in TCS. And Mr. Ajeya Bandyopadhyay, who is working in circular economy area in IFC World Bank Group. So we have three eminent panelists. I'll start, we'll end the discussion about 5:45 maybe, because after that we have several programs for the alumni and cultural program also. So maybe 5:45 will end, and I understand Mr. Barua also have to leave quite early. Yeah. So Mr. Barua, is it okay? Yes. Okay, that's fine. So basically, I'd like to have interaction with the students after some general some general idea about what the allied industry seeks from the chemical engineers. Yeah, so I like to call upon first Dr. Kaushik Bhattacharya of Steel Authority to say a few words about what is his expectation of the chemical engineers, from the chemical engineers in steel and other areas, in metal industries, to be very specific in steel industry, especially in marketing area. Mr. Bhattacharya.
Thank you. Thank you. Thank you, Dr. Roy, for your few words, and good afternoon to all. And congratulations, big congratulations to all the students that you are earning a really globally recognized credential, and wish you all the very best in your future. So, coming to the topic, so role, first thing I will say, I will not take much time. I will say only 3 strategic things and 3 tactical things. So the first thing, what I should say is that you should continuously analyze what are the things expected from you and what are the things you are expecting from the industry or from the organization. So role is basically fulfilling the expectations, and by fulfilling expectations you create value, and value creation is basically the lifeline of all businesses, be it chemical or be it any other business. So second thing, knowing your expectation, because you are very young, it may be difficult, you don't know yourself, because this has happened to all of us. So you should know yourself. Then when you know yourself, it will be your role to decide what kind of work you will be doing and where you want to do. The best thing is you should be doing the right kind of work in the right kind of organizations. So you have to design your future. So that is your second strategic role. Third thing I should say that whatever be the organization, whatever be your job or task in hand, you be future oriented. So you can have a vision at least that what you want to be, how you want to leave a mark in the industry, and you cannot be a celebrity unless you become a film star or something like that, but you can be a celebrity within the organization. So in organizations, there are a lot of celebrities. When you enter an organization, particularly large professional organization, you will see that you can be a celebrity within the organization. So that can be your third strategic role. Tactically, what I should say that whenever you go to the first organization in the job, the most important thing is acceptance in a group. So you have many job ready skills, you don't have much difficulty in performing the tasks. That's true, but your acceptance in the group is very important. Second thing is that what I think is a common thing is safety, because to work is nothing, but to work safely is everything. So you can take this in the broad perspective. So more you widen it, more it will give you some umbrella, and many things can be encompassed in this. So you take care of your own safety, you take care of your company's safety, you take care of the environmental safety. So the safety thing you should not forget. And the last tactical thing what I should say is that in any company when you are joining, after some time you should be thinking that yes, this is the thing what I am getting, this is the another counter offer I am getting from another company, like that. But you should try to enhance your market value over a long period of time. So in some company you will get a very lucrative initial offer, but your market value in those companies may not increase that much. So you think of your job, I can't say, but it happens if you are really analyzing your environment every day, your situation every day, your friend's situation every day, then you will understand that which are the jobs are really enhancing your market value rather than initial salary or take-home salary right now. So these are the three plus three things that I wanted to say, and I can take questions after this. So session handed over to Dr. Roy.
Yeah, thank you, Dr. Bhattacharya. So now over to Mr. Barua. You have a long experience of industrial automation as well as the data analytics and all, and in TCS. So will you say something about what are your expectations from the young budding engineers, especially chemical engineers?
Right. Thank you, Dr. Roy. I hope I'm audible, right? So a very good evening to all the distinguished teachers, professors, industry experts, and my dear fellow students. It's been now 27 years since I passed out of this hallowed portals of this department. I passed out in 1996. And what I am today and the honor of being on the stage to address you belongs to the university and what it has made me of it. So I thank this university, this department, for making me what I am. So with that, I will just try and address the question and the topic for this discussion. And I'll start with a real life incident that happened to me. So I worked in SAIL initially. So I worked 1 year in Steel Authority of India Limited. And in the interview round, so there were 2-3 rounds. And in the interview round, someone asked me, or one of the interviewers asked me, are you okay? It was the final round actually. Are you okay to work in the coke ovens? Now, I've never seen a coke oven in my life before that. And I said, yes, of course I can. I was desperate for a job, as we all are, right? Starting off our careers. And I said, of course I will. Thankfully, they didn't put me into coke oven. They put me into CMO. But I had the opportunity of visiting certain coke ovens, all right? And believe me, if you look at a coke oven, and in 25 years back or 30 years back, you wouldn't have again gone back there and started to work. Like it was like, smoke belching out of some containers and stuff like that. It was a very, very unhealthy kind of environment. But the industry has changed dramatically post that. So the coke ovens of yesterday is not the coke oven of today. So there has been a vast change in the environment and the technology that is used in coke ovens today. So I'll give you another example. I shifted job and I said I have enough of coke ovens and stuff. I moved into Hindustan Petroleum, all right? And in Hindustan Petroleum, I was posted in the Mumbai refinery, okay? And in the Mumbai refinery, it is beside the sea coast, and it rains very, very heavily in Mumbai, and sometimes the storms comes in and all those kind of stuff. So what happened was, one day there was heavy rains coming in, and there was a flange that was leaking on the top of the VDU tower, the vacuum distillation unit tower, which is what, nearly maybe 30, 40 feet, I don't remember exactly, maybe 40 feet tower, okay? And the technician there just flatly refused to go up the tower and repair that flange, all right? So he said, I'm not going up. And I was the trainee engineer there. And my boss said, you climb up and go and tighten the flange, It was a monkey ladder. I'm not sure whether anyone has worked in a refinery, but I'm sure many of you would have seen that. And, it was a monkey ladder. I was in my raincoats and I was climbing up that ladder, okay? And I reached up, tightened the flange, and came down again. It was like a movie scene, right? For me, it was like a heart-stopping scene for me. So I decided I had enough of that, and after 5 years, I again said enough, and I quit and moved into a completely different field, which is now IT. So the point that I'm trying to make here is that how would things have been done differently if it was today? All right? So today, we are using drones and satellite imagery to kind of do the same job. So what we do something called constant monitoring of such flanges of, such high, towers or high installations, which are very difficult to climb or, do a preventive maintenance by climbing at regular intervals, checking at regular intervals. So what do? We have imageries of drones and, even satellites, which track these images on a regular basis, 24/7, 365 days a year. And these images are captured and then analyzed. And if there is a leak, or if there is a kind of potential threat that is kind of envisaged, it is immediately taken care of. So what I'm trying to say here is that there is a lot of innovation that has gone into this industry since the last 30 years, and IT has played a very, very major role in that. So, but the base, as Partha also said earlier to me, the base remains chemical engineering. So, whether it's IT, which is an enabling industry for us, the core remains chemical. If I do not know which flange and how much pressure, temperature to maintain, the logic, the algorithm on which I have to write it will not be ever written. The machine language that you talk about, the AI, ML, will not work without the core domain knowledge that you have. In TCS today, we have around 600,000 plus 615,000 associates, on our payrolls across the globe. Do you think all of them are IT engineers only? Absolutely not. We have people from every aspect, from finance, from banking and finance, to doctors, to legal counselors and legal practitioners, as well as many chemical engineers. So they provide you the domain knowledge. So IT is nothing without that domain knowledge, and that is why we require those chemical engineers. So IT is, of course, one area where, chemical engineers can play a very, very relevant part. But apart from IT, there are several other emerging fields that are opening up. So one of them is, for example, the transportation industry. So we are seeing a proliferation of EVs, right? And EVs essentially are powered by lithium cells today. But there's so much of work that is going on in terms of producing energy from, say, sodium and calcium also. The challenge is sodium and calcium are heavier, so it's difficult to kind of pack that into a vehicle. But it is so abundantly available, sodium and calcium, that if you're able to tap that energy, we would have solved the problem of, batteries and be able to, fast track the battery industry, which is going to be a big, industry in the coming years. So that is one area. The high-tech industry, silicon wafers, so there are many technologies or many material that is coming up, which is an alternative to silicon. Say, for example, we have this something called, I'll tell you, cubic boron arsenide, all right, which is 10 times more efficient than a silicon semiconductor. So a lot of research is going on in these areas where we are saying is, how can we have semiconductors which are better and faster than today's silicon? All right, so there is another industry for you to look into. Biotechnology, we all know, right? Bioscience and chemistry are intermingled. So today, whether it's the feelings that you get when you look at someone beautiful, your classmate or maybe someone on the street, doesn't matter. So it's a chemical reaction that's happening somewhere in your brain, right? To the digestion of the food that we have, it's also a chemical reaction. So the vaccines that we have. So biotechnology, bioscience is another area where chemical industry is going to play a very, very significant part. Manufacturing industry, I think we have experts here who can talk more, but manufacturing talked about how coke ovens, etc., have changed and how we are able to better, prevent the pollution that's happening from there through innovative technologies. Geosciences, another area where chemical industries plays a very significant role. Nuclear science, technology, where again, a lot of work is being done as to how we can produce energy and also use it in radionuclear technology, imaging and stuff like that. Textiles. Textiles is another area where chemical engineers are in great demand or are going to be great demand. So you have wearable shirts which have carbon nanotube technology embedded into that, which will transmit your daily health. If something is out of gear, it will actually give out a message saying that something is wrong with you. So wearable shirts, like wearable phones that you have, right? So you can wear those shirts, it will transmit, it will monitor your health and will tell you what's wrong. Even actually technology exists or is being experimented, as I say, where if you meet with an accident, say, it will send out an alarm to the nearest police station or ambulance or whatever, saying that the shirt will send out an alarm. So things like that. I think so the scope for chemical engineers in allied industry is humongous, and it is there for us to pick it up and run with it. I think the scope is tremendous. So with that, I'll just hand it over back to Dr. Ray.
Thank you, Mr. Barua, for nicely elaborating the areas where the chemical engineers can play a big role. In fact, the world is changing now, and it's changing very fast. And nowadays, there is not much of difference between the different branches of engineering. It is only the engineering that is the most important thing. There's not much of difference in chemical engineering, mechanical engineering, metallurgical industry, material science. There's not much of difference. Information technology, everybody can fit in everywhere. So one has to be very versatile, and one has to fix in mind and has to adapt to the changes the world is first experiencing. So we have another member of the panel who is a very learned gentleman, Mr. Bandyopadhyay, who has worked in the area of circular economy and environment and all these aspects, and he was connected with IFC of World Bank Group. Mr. Bandyopadhyay, can you say a few words where chemical engineers fit in these areas?
Thank you. At the very outset, I would profusely thank all the senior members of the Centenary Celebration Committee for giving me this opportunity to speak at this historic moment of the department, and I feel deeply honored with this opportunity. So I work in an organization which is very different from core chemical industry. So I am part of World Bank Group, where I lead the Asia Pacific investment vertical for climate change related investment or the green investment, where essentially the major part of my role is to identify new project ideas, new program ideas, Pan-Asia, where the World Bank lending investment as well as a lot of our advisory and research program can go to greening industry, greening infrastructure, and greening the larger economic development, both private and the public space across Asia Pacific region. I entered into this organization a couple of years back, and before that, for 1 year, I was a senior advisor to United Nations Development Program in New York, where essentially my role was to focus on mobilizing climate finance at scale in the vulnerable region of Africa. And before joining United Nations in this senior advisor's role, I was almost for 18 years in management consulting, working in the different areas like core business advisory, government policy advisory, and also on sustainability and the climate advisory across many regions. So in World Bank, essentially it was at some point of time the seat of the learned economists, as many of you would be knowing. We had the alumnus like Dr. Manmohan Singh, Montek Singh Ahluwalia, Kaushik Basu, all the glittering names in the economic space, and also several other the leading economics across the world. But as we speak today, this organization has 40% of their workforce who are the technologists. And believe me, it's being largely an US dominated organization. The whole chemical engineering skill was very popular in United States. And out of this 40%, nearly 25 to 30% are the chemical engineers. The whole reason is the whole world of development, whether you call it climate change, healthcare, infrastructure, transportation, they have realized that this development is actually happening at the interface of three things, not only just policy or the role of the economists, but at the pretty much under the influence of the technology and also finance. So such a large international organization like World Bank or United Nations need to have a lot of technological talents who bring the fresh ideas and who bring the implementation skills on the ground to make the development happen. And many of my previous speakers were sharing that these opportunities are just not in industry, but in spaces like transportation, places like healthcare, the new materials, electric vehicles, the new aviation fuels, and so on and so forth. So when we talk about today allied industry, one term which probably I would like to use where I see a lot of opportunities are emerging, that is in the industrial ecosystem. So it's not just about your core industry, but the core industries today are very frequently getting shaped, reshaped, also disrupted quite frequently by many forces. So we talked about certain technological forces. Mr. Partho Chatterjee has given a wonderful presentation on some of the latest trends. I will also add two things, which is our geopolitical forces, which is really hurting us day in and day out. And that's what you are also today perhaps reading every day. The war in Russia, Russia-Ukraine war, the tension between US, China, and the Taiwan, which are shaping the landscape of industry tremendously. There are forces like, we have seen COVID, the kind of what we called the sudden changes which were completely unexpected, that has jeopardized the supply chain, jeopardized the industry. And there are, of course, the technological changes. Now, given those changes which were impacting a lot of these core brick and mortar industry, so today when you look at your opportunity space is just not in your core industry, but also go beyond that. Look at your entire industrial ecosystem, which involves a lot of startups, because today's major innovations are not coming really from the large industries, but hugely from the startups. You look at several R&D institutions, R&D companies who are doing fantastic job. We are part of this ecosystem. Look at the financial institutions which require technological talents in a very big way. Look at the policy think tanks who need the inputs of the technocrats, the technologists, to make the policy more comprehensive. And also the academics, which is a very wide field, which are part of the ecosystem. So that whole ecosystem view is very important. I know it's sometimes difficult sitting at your level. In fact, if I think of, when I was passing out, where I had that enough maturity and the whole idea to understand the ecosystem, of course not. But today you have a lot of resources wherewithal to really understand that your opportunity is just not your core chemical industries. Yes, that's definitely a big area, but you have several opportunities beyond that. Second thing which I want to highlight that, see, in most of the large industries, if you see today, there is no guarantee in jobs. There is also no guarantee in the skills. There was a time when there was a guarantee in jobs, but there was no guarantee in jobs, but there was guarantee in skills. People used to say, okay, if you are a good IT developer, a digital specialist, or a chemical specialist, you may lose job in one industry today, but you will get somewhere else. But today that's also not true, because the rapid technological advancements is making jobs as well as the skills redundant almost every day. Even we heard about some of the previous speakers talking about learning, unlearning, and relearning. Yes, that's very important. But the whole technology of ChatGPT and many other things which are making us realize that you will have a learning assistant today. So you may not need to learn it, you may not need to absorb it, somebody else may help you to learn it tomorrow. So what's going to happen in this scenario? We really don't know. So in this context, it's almost like when a pilot is navigating a plane under the heavy cloud, just with certain aids and assistance and a lot with his experience and expertise, that how to navigate through and reach the destination in the most convenient fashion. So I think that's what something very important, and keeping that in mind today, in fact, World Economic Forum very correctly said that in future, the skills or competencies which probably the young graduates, whether from the engineering colleges or management institutions or wherever it is, would be requiring, is not just your technical skills. Yes, you need to have a very good analytical ability, mathematical ability, your understanding about data analytics, or your core engineering and all that. But there are few things which are also becoming very important. Your curiosity. Are you really curious to understand what's happening in your surrounding? Do you read a lot about those developments? You need not be an expert in every field, but you should be well aware to catch the right wind at the right time. Second thing, your creativity and inventiveness, as well as your innovativeness. I was very pleased to hear from this older gentleman before lunch who was talking about that several years ago his professor in US talked about that even beyond knowledge, what is more interesting and important, that's your creativity. And that whole creativity skill is becoming very important. Just think of today, an organization like Accenture, okay, which was originally a digital consulting firm. They are acquiring the firm which are into the advertising. They are recruiting the artists. The reason is that today, think of a product like iPhone, which has more innovative content or an artistic content than a technical content. So if you have to improve your product over a period of time, the technological brilliance has its limitations. Pure technological brilliance has its limitation. So what it needs to today is to synthesize a lot more skills, lot more competencies, lot more capability which are beyond the rim of your core capability which you are learning day in and day out. So that's where very important skill is the curiosity, creativity, inventiveness and innovativeness, which will help you to become agile, which will help you to remain flexible, fungible, as well as adaptable to the new environment. So I think that's where I would end. And one thing very important, that there was a time when industry really rewarded the deep specialists. So if you were a specialist in one particular field, you had a lot more demand in the market. Today, there are a lot more acceptance for the deep generalists. So we are just not talking about shallow generalists who are the jack of all trades floating around from here and there. We're also talking about the deep generalists, and there is a terminology they're called the T-shaped individuals. So you have the sufficient depth, also you have the sufficient breadth to offer in every organization. And that's where I think you should aspire. There are many things you can do at this point of time. You are just passing out from the college. try to take small projects in different areas. You need not be in your core chemical engineering. It can be somewhere else. Try with many other things if you have the flexibility and luxury to do that. So that as you go along, you remain agile, you remain flexible, you remain deeply rooted, as well as you can spread your wings across different domains. So that's where I would stop. These are the few comments I could have.
Thank you. Thank you, Mr. Bandyopadhyay. I see here amongst the audience, Professor Siddhartha Datta. I know that you have introduced many courses which was not being taught during our time. I mean, although you are 4 years junior to me, but you have introduced a lot of courses which addresses the ecological balances and all. So can you speak a few words? What are the changes you have brought about in the curriculum of chemical engineering in this university? I think the mic is there. I'd like to introduce Siddhartha Datta, who was a faculty of chemical engineering, and he was the head of the department, and then he went to the administration department. He became pro-vice chancellor. Siddhartha.
Yes, we have made a lot of changes in the syllabus, particularly after 90s. By that time, I was associated with many organizations related to pollution control technology. I was associated with West Bengal Pollution Control Board, Central Pollution Control Board, Ministry of Environment and Forest. So I felt that the course on environmental science and engineering, that would create a new dimension in the field of chemical engineering. Earlier it was in the, or within the field of civil engineering mainly. So in West Bengal Pollution Control Board, myself and Professor Sannal, Professor Shamul Kanti Sannal, told them, why don't you recruit chemical engineers? This is the core area of the chemical engineering where they can contribute a lot, particularly for mitigating the pollution control problem in industries. So I introduced this course, and I am happy to say that many of our students are now engaged in pollution control area of many industries. Next, in 2004-05, when I was the head of the Department of Chemical Engineering, that is also due to my experience in different industries. I used to visit many industries, being associated with many organizations like that. So I felt that safety engineering, that must be also included in the chemical engineering course. And today people are very much concerned about not only the safety of the worker, safety of the people living around the factory. So I introduced that course, and now initially I introduced that course in the elective areas. We have a lot of elective subjects. So pollution control engineering, that is also one area in the, or one subject in the elective. And later on, we introduced process control, safety, etc. in the elective areas. I am happy to announce that I think, I don't know the latest syllabus that has been adopted by the department, but in our time, the pollution control and engineering has been made the core subject in the field of chemical engineering, and process safety and engineering also has been included in the chemical engineering course. That is all about the introduction of new courses in the field of chemical engineering.
Okay. I mean, it's a good development. I mean, curriculum also is getting changed day by day. And I also feel that there should be some changes in curriculum also for data analytics, business analytics, and all these. These are very essential because I find most of the students who, after graduation, they are joining in IT industries. So these are the also areas where the chemical engineering curriculum should take care. I mean, what I feel. I mean, anything you want to supplement on this?
Yeah, absolutely. Data analytics is prevalent and it's all pervasive at this point in time. But again, as I said, which data to analyze, what to analyze is most important. The algorithm